So what I wanted to talk about as the first speaker of the conference is to kind of give an overview of how architecture or the design and construction of the built environment is being used to mitigate climate change. Some of the strategies that I'll be talking about are things that you may see around you in, the built environment, or the sort of areas where you live and work and go to school. Other things maybe seem a little novel or new and are things that haven't been adopted yet or haven't been pursued fully yet, but are ones that we need to start incorporating more in order to achieve a better balance and resiliency in light of the impacts of climate change. And these are obviously topics and skills that we teach our students here at College of the Canyon so that they can become professionals and help address the changes of climate change that people in the world are experiencing. I think it's also important to talk about the sort of equity component of environmental and social justice, and that as designers, whether we're architects, interior designers, or decision makers in any way, shape, or form, that we can advocate not only for ourselves, but for those that simply can't, so maybe young people or the elderly or people that are disadvantaged in some way, that, this discussion relates to everybody. It's not just select few. It's not an exclusive club of people that should benefit from, the things that are needed to pursue in response to climate change, but it's something that's sort of a worldwide campaign. And I think that's obviously one of the motivations of why we're meeting here this morning. So we tend to use the terms adaptation and resiliency in our effort of survival, basically, that humans are engaged in as we continue to face and are confronted with sort of ongoing and regular crises and the stresses that are being imposed by climate change and global warming. And these are our new normal. We can't simply turn a blind eye to them, obviously, because these issues have become so pronounced, so much in the forefront of our daily lives, that we have no choice but to approach them and to try to, if not resolve them, then find ways to survive in light of them. And so we think of the multitude of issues that we need to address both locally, in kind of the local areas where we live, and globally as well, because it's all sort of in a larger scale related. It almost appears somewhat impossible to be resilient in face of all these dangers. I know in some of the conversations we've had with our friends in Romania that a lot of the same exact climate issues that are being faced, in Eastern Europe are the same ones we're facing in Southern California, where I'm at, and vice versa. So it's really interesting, the parallels. And so that being said, we do have much of the sort of technology and the scientific knowledge that's needed to address a lot of these issues. But unfortunately, where we really need to improve is how do we navigate the sort of political and economic and the psychological hurdles that often stand in the way of our substantive ability to address climate change. And so designing for resiliency is obviously something that's very connected to the physical world around us. And we reside at a sort of a sensitive connection between our built environment and the natural environment that operates at scales that are much larger and more powerful than we have the ability to, easily and safely control. So on this slide, there's obviously some various dangers that we all face, in the current age, because of some of them are just natural disasters, some of them are human derived, and climate change is an aspect to all of them. And so there's this tension between the built environment within which we live and the natural environment that exposes humans to a lot of these dangers. So how do we even start to address this stuff? You know, climate change and dealing with humans' place in the natural world is obviously not something new. It's been going on for thousands of years, but as the human population has gotten larger, as our built environment has gotten more sophisticated, we've needed to have more structure, more organization to how we order our lives and how we can, as a global community, address these issues. So with that in mind, the United Nations has developed a variety of sustainable development goals. We can see the main ideas or the main strategies identified here on this slide. And so this provides sort of a political framework for the members of the United Nations so that they can have some guidance for achieving these goals. And these 17 principles are ones that you should become familiar with, because I think that they are they provide a great framework for addressing global issues. We're going to focus on one particular one as we talk about the built environment, which is the Sustainable Cities and Communities goal. And what this particular development goal is centered around is making cities and human settlements that are inclusive and safe and resilient and sustainable. That seems self-evident, obviously, but it's not always something that's at the forefront of the political and economic decision-making process, which is obviously something that even Constantine was referring to a minute ago. And so these characteristics for this particular goal are intended to not only create, but to maintain healthy communities. And we found that, the built environment that so much of us lives in is often at odds with providing these qualities. And so there's a lot of disparities faced by people around the world. And it's become even more acute because of the repercussions of climate change, So with that in mind, how do we in a sort of nuts and bolts or a structural way start to whittle away at achieving these goals? Well, one of them is to have an understanding of what the conditions are. So here in California, one of the tools that we have as designers and as decision makers is a lot of climate data, a lot of climate science. And so we need to obviously understand the conditions that that are endangering our lives so that we can somehow address them, at whatever scale they may be. So CalAdapt, which is a screenshot that we see here on the screen, is a resource available from the state of California that takes all of the climate science that's being produced by the various research universities and agencies throughout California, and it sort of compiles them into one resource. And so it takes a look at a variety of climate change specific issues. In particular, this one is sea level rise. And so they have projections of where as the seas rise, which they are doing and are expected to continue to do over the next century or longer, where will they have the greatest impact, or what areas are the most prone to impact by sea level rise? And so as politicians or decision makers or developers or architects and designers, city planners, we can make educated decisions to avoid those areas or to remediate or try to resolve any kind of potential danger before it happens, rather than actually putting people in harm's way. So being informed about the changing world around us, using credible and data-based scientific information will allow us to improve the design of not only the individual buildings, but also our cities and our communities. And so that's where an understanding of science is so critical to designers, because we need to be able to see these impacts on a large scale, so that we can make our sort of micro decisions on the scale of an individual building project. Another part of climate science obviously relates to global warming, which is something that we're fairly familiar with. Unfortunately, there are quite a few people in the world that don't subscribe to the idea that the Earth is warming, although we do have adequate information and data that shows that the climate has throughout its entire life gone through warming and cooling cycles, but most recently, in light of the Industrial Revolution and carbon emissions and greenhouse gas emissions, a lot of the extreme global warming that we're experiencing is human caused. And so this map is a map of the United States showing where there's sort of extremes of global warming that are occurring and will continue to occur. And so where we live in Los Angeles, which is on the Pacific coast of the United States, we've seen temperature rises of several degrees on average. There's other areas, even in, let's say, the Rocky Mountains, which would be in the Utah, Colorado area, where they've seen average temperature rise of 4 to 5 degrees, and that's fairly significant, such that it alters the ecosystem, the natural ecosystem. Why is that important to us? Well, just on a very practical level, in Los Angeles and Southern California and throughout the Western United States, we get a lot of our drinking water from the snowpack that's contained within the Rocky Mountains. We also get a considerable amount from the Sierra Nevada mountains that are kind of hugging the California-Nevada border. So if these areas are going through a significant natural change in the ability for there to even be snow and for water to be stored in the snowpack, if that diminishes, then we have 20, 30, 40 million people that simply will have limited access to water. And so that's obviously a very acute issue that we need to be aware of and to address. Along with global warming is the impact of extreme heat, and that's something that we I think everybody's experienced quite a bit in the developed world, where the temperature of developed areas that are built on, tends to be warmer than the sort of natural vegetated areas or rural areas, and it's simply because of the sort of materials, the construction materials that are used to build cities. If you think about our roads, a lot of roads are made with asphaltic concrete, or asphalt, which is basically a black petroleum-based tar product. The physical characteristics of that material, the color of that material, are such that as it's being bombarded by solar radiation throughout the day, instead of that solar radiation bouncing back out into space like it ordinarily would, it's being absorbed into the earth and then being re-radiated out as heat. And so that's one of the factors that increases the heat in developed areas. And so in a dense urban environment, the temperature of that area might be as much as 10 or 15 degrees warmer than it would be in the sort of rural or native landscaped areas, the natural areas. And so as the earth gets warmer and warmer, we have these extreme heat days, which are dangerous for people. People can obviously die of heat stroke, and do every year. And it's in some ways a consequence of the materials and the colors of those materials for our built environment. So being aware of that, being sensitive to that, we can actually start to select other materials and other colors that will reflect more of that solar radiation out into space. So that's a decision-making thing that we can do, being informed by and having an understanding of global warming and the extreme heat that's caused by it. So we can see there's some very obvious examples of this, of the heat island effect occurring. If we look at cities, for instance, New York City, which is a photograph on the left here, we have Central Park, which is a large park in a very urban environment, and the temperatures within Central Park are traditionally considerably cooler, 10 degrees cooler or more than the surrounding city. And that's why a lot of people go into the park during the warm summer months to enjoy it. And so that's a very obvious example of, just the difference in materials, or the difference in the built environment versus the unbuilt environment, and how it affects the heat island effect. On the right, we have some infrared photographs, or actually the top one's an infrared photograph that shows more scientifically the temperature change of surfaces that are being bombarded by solar radiation. So we can see in the foreground a parking lot that has an asphalt surface, and in the background is grass or turf. This is probably a park, and so the temperature differential is as much as 40 or more degrees between the two, simply because of the difference in materials. They're both receiving the same amount of solar radiation, but one material is reflecting more of that radiation back out into space, and then the other is actually absorbing that material and re-radiating that heat out, which makes it obviously dangerous for people and creates the extreme heat effect. So one of the strategies that we can, another strategy that we can continue to employ is the idea of simply just planting trees, more vegetation. So the movement for urban forestry is an important one, but it's not as simple as just planting trees. Here in Los Angeles, there is a considerable disparity between communities that have trees and those that don't. And it often is a factor related to socioeconomic issues. So for instance, on the left, where we have the neighborhood of Boyle Heights in Los Angeles, versus on the right, which is a very upscale community called Brentwood, kind of near Beverly Hills. And both communities are fairly mature and fairly established, but the residents of Brentwood, traditionally have had a lot more money and the ability to not only plant trees, but to care for them over time, so that after 40 or 50 years, those trees can thrive and create a canopy that provides shade and stops the solar radiation from, hitting the Earth's surface and creating the heat island effect. Whereas in Boyle Heights, where the community may be more transitory, people are coming and going, there's probably less sense of ownership. A lot of the houses or residences might be rental properties where people don't necessarily own them, and so there's less ability or desire to plant trees, for instance. And so although the idea of planting trees may seem very simple, it's tied into much deeper, much more complex decisions, long-term decisions, and economics that aren't always readily resolved. So obviously, if we're going to be dealing with things like the heat island effect, so much of what we do in sustainable design revolves around the sun. The sun is a very important aspect or element that we consider in sustainable architecture, because of not only the way that it heats buildings, which we may want to heat or may not want to heat. Here in Southern California, we traditionally want to keep buildings cooler, so we want to protect them from the sun, but also for natural daylighting. We want to be able to allow that natural daylight to come into our buildings, so we don't have to have artificial lighting. So there's this sort of tension between the sun and how we harness its, the solar radiation that it provides. We want to allow the daylight in, not directly, but maybe through, northerly light or bounce light. But we also have to protect against the heat that it generates. So for a lot of residential homes, that particularly here in Southern California, I can't speak to what you might see in Eastern Europe, but a lot of our newer homes that have been built over the last 20, 30, 40 years are developed by large corporations that build homes like this, freestanding single-family homes, and they really don't have any sort of acknowledgement of, let's say, the sun. They have windows, obviously, that can let in natural daylight, but they don't do anything to deal with the sort of shading that's needed to protect the house from excessive solar radiation. They're really intended to, look like a sort of prototypical or a traditional home. That's the most important aspect of selling the home, but not really dealing with the performance that's needed to make it sustainable. And so, even though there's a lot of attention put into the detailing of the home and the materials used, they're really not put there for performance reasons, but for aesthetic or appearance reasons. And I think that's a huge part of, at least in Southern California, an aspect of our built environment that should be addressed immediately. And so that's one of the important things that we try to teach our students is in residential design, the design of homes. How can you start to address things like climate change, through your understanding of the path of the sun and how it may impact that building. One of the simplest decisions is to plant trees, and so one aspect of dealing with the sun is sort of stopping its direct solar radiation hitting the building in the first place. And so being strategic about how you can use vegetation like trees to shade a building, and then also vegetation plays a larger role in providing environments for the biome and obviously plant insects and pollinators and birds and kind of the larger environment around us. So it's a really unique project. This one's actually in Australia. It just shows how, in a residential design, this is obviously a higher end home, but we can be creative and create spaces, both internal and external, that accomplish a lot of what may be needed to address, let's say, the impacts of the sun or even natural ventilation, as well as creating occupiable and useful space. So this project has a sort of the roof extending over like a shade canopy, and the amount of solar radiation is tempered or reduced, but also this pool of water, which has obviously a very nice appearance to it, aesthetic feature, but it also helps cool air that's brought into the house through natural ventilation through an evaporative cooling effect. And so as a designer, we look at how can we achieve the most out of our building forms, out of our spaces, out of our materials, so that they do more than just simply look pretty, but they can be a much more efficient and effective solution. Since the pandemic started a little over 2 years ago, another aspect that we've become very sensitive to is the idea of bringing the natural environment into our interior spaces of our buildings. This is not a new trend or a new consideration for designers, but it's something that's obviously become more just sort of the general public has become more aware of. And so one of the terms that's used to describe that use of vegetation inside of a building is biophilia. And it has a variety of benefits. The incorporation of vegetation in a building helps improve the interior air quality because plants have the ability to filter air, and so it takes out some of the toxins and improves the air quality. It also has a psychological aspect that a lot of people appreciate. It's not always a conscious thing, but the idea of having the natural environment inside helps people feel better. They feel healthier, and in the case of commercial projects like an office environment, that they actually become more productive in the sense that they have a better sense of well-being working in those spaces, less chance or less statistic probability of calling in sick, for instance, because they actually might enjoy being in the space, because of the richness of the interior environment. But obviously, as a designer, there's implications of bringing vegetation into a building. Now we have to, these things have to be watered and maintained. And so there's a lot of technical issues that go along with that, in addition to just simply providing space for them. But we're starting to see, internationally, how biophilic design can enrich not only individual buildings but larger developments in citywide. And so it speaks to the idea of urban forestry, and we'll see in a minute even urban farming. And so how we as humans can embrace nature and incorporate it more into our built environment. So I'm really excited about the idea of urban farming. Obviously humans need food. I mean, that's readily self-apparent. But as our cities grow, as the impact on the environment is extended, further and further out into what we might call green fields or undisturbed land, we diminish our ability to actually grow the food that we need. And so we may start to see, and I think we are starting to see on slightly larger scales, farming occurring in our cities. And if done properly, this can sort of have the cumulative effect of not only providing food for people in the city, but also addressing some of those issues of extreme heat and heat island effect at the same time. And so it obviously has to be very thoughtful. There's issues of how do you even harvest food? What kind of foods are appropriate to grow in the city? How do you balance it so that there's an access to pollinators, bees and butterflies, and all the sort of nature's helpers that are needed for a farm to thrive. But how do you do that in an environment where you may have in a city block 500 people or more living there? So that's obviously a sort of rich interplay that a designer would need to do with somebody that's an expert in this type of farming in order to make it successful. But we've seen examples here in the United States, and I know in Europe it's actually a bit more prevalent of case studies of how this is being done successfully. And so I think we'll see this expand in the not too distant future. So I touched a little bit earlier on water. Obviously, that's a very important aspect for all of us. We all drink water. We're all going to be drinking water probably in the next hour or two. So it's just a critical part of our lives. It's something that we can't avoid. And yet, interestingly or unfortunately, so little of the water that we have on the earth is actually suitable for drinking. And so that is a critical issue that we need to address, the idea of water scarcity. And it's unfolding right in front of our eyes. Here in Southern California, we're almost continually in drought conditions. And yet so many people seem sort of unaffected by the challenges. Our governments have put in restrictions on how our ability to water ornamental landscapes, say gardening and whatnot that you might have on a property. And yet so many people still water their lawns or have grass or turf that's inappropriate for this climate. And so there's sort of a animosity towards conserving water, but it's something that we rely on for our daily survival. So we as designers have to understand the different scales of what is entailed in providing drinking water, which is commonly referred to as potable water. That's sort of the technical name for it. And it's one of the most, I would consider, salient luxuries that we have in the world. We take for granted that at least in the developed parts of the world, we have easy access to potable water or drinking water that's safe. And again, that you can get to water fairly quickly if you needed to. A lot of parts of the world, they don't have that at all. In fact, people have to travel long distances to even get water, and often then that water is maybe not safe for drinking. Where we in the developed world see glimpses of that, of course, is when there are natural disasters that affect us, whether it's, say, a fire or an earthquake or something like that. All of a sudden, our ability to access safe drinking water is compromised, and we realize how acute and how critical it is to our lives. And so our ability to sort of reduce the stress on our sources of water, whether it's the aquifers underground, the sort of below ground water storage that nature's provided for us, that will at least help provide some reserves for when we do have crises, that water will remain available to us. There's always a desire, I know here in Southern California, because we live so close to the Pacific Ocean, it's just maybe half hour's drive from Santa Clarita. Why don't we just simply desalinate the water and make that drinking water? There's so much of it, but unfortunately desalination, although it's obviously possible and is done in some parts of the world, it's extremely energy intensive. And it has byproducts that come from that, of the brine and the salt, the sea salt, that are extracted out through the desalination process. And unfortunately, those elements are pumped back into the ocean, which has significant negative impacts to the sea life and the sort of aquatic ecosystem around there. So we really haven't found a great solution for desalinating ocean water yet. And there's obviously a lot of parts of the world that aren't near the ocean, and so they wouldn't be able to benefit from that. So, one of the primary strategies being employed as far as water is conservation. That's probably one of the most important things that we can do, within our control as individual people, and then also as building designers, is how can we reduce the water consumption footprint for a project. So we see strategies, and we incorporate them a lot here in Southern California for capturing rainwater. We don't get a lot of rain here in Southern California, but when we do, we can obviously capture that water, and that can be used for landscaping. Obviously, we're going to have plants to help with combating the heat island effect. We may need to water them from time to time, so being able to have a store of rainwater to do that is important. We can also use gray water, which is basically water that comes from in the building, but it's not from a toxic source. So it's not from a toilet or anything that's contaminated with food waste or human waste, but typically laundry, washing machines, or maybe a hand sink or something like that can be filtered and processed. That water can then be reused for non-potable uses. So we wouldn't drink it, but that water can be put to a second use, so we can at least extend the effectiveness of it for a project. So, being able to incorporate the equipment and the systems that go along with a gray water system are something that designers need to be aware of, that technology, the spatial implications, and just sort of how those systems work, so that we can effectively and sort of elegantly incorporate them into our designs. I'm also a big fan of natural ventilation, and so there's a lot of comfort that can be provided by natural ventilation, and our ability for a building to sort of breathe and not rely on artificial means for not only ventilating or providing fresh air and exhausting the used air out of a space, but also for cooling or potentially even heating that building. So there's a lot of interesting sort of performance and aesthetic possibilities that go along with that. And so in order to naturally ventilate a building, we've got to be very considerate about the orientation of the building, because we may need to take advantage of natural wind patterns that may occur on the site. Obviously, we're going to need to take into account shading and the sort of design of the envelope of the building, or the skin of the building, because that's going to play a role in our ability to let natural fresh air into the spaces. So how do we go about doing that? Through windows, and how does that interplay with shading devices? So we can see an example on the right here. This is a project in Africa that was recently built about a couple of years ago. It's like an apartment building, and it has on the different sides of the building a variety of different skins, almost like what we might call dual skins in the profession. So that not only does it look pretty, it has a really beautiful mosaic pattern to it, but this outer white lattice work is providing shading for the wall behind it, the exterior wall behind it, which is where the windows are that people open and close in order to allow natural airflow into their residences. This is, as we come around the side of the building and we look at the actual, maybe this would be the south side here, which is kind of facing the sun. And on the right side, there's an exhibit or a drawing that shows a section to the building. So as if we cut through it, vertically, what would be the profile of these walls. And so the designers have, taken into account shading from the excessive sun, either through the addition of this kind of lattice secondary skin, which you can see in the bottom section, so that provides some reflection of the sunlight, and obviously they've painted that lattice white because that's a very highly reflective color, what we might call a high albedo color, which reflects light, back out into space more readily. Or they've used a strategy of providing a sort of deepened balcony. And you can see in the section, they've shown where the angles of the sun are and how that balcony can shade or shield even the glass surfaces behind it from being directly struck by the sun. So reducing the solar radiation impact on the project. So there's obviously a sort of, as designers, as a balancing act or a sort of synergy between how we achieve the things like shading and natural ventilation and do it in a sort of elegant and almost artistic way that might be also, culturally and appropriate to whatever that locale is. So this lattice work has a really beautiful appearance that would probably only be appropriate in this particular part of the country. It might look out of place elsewhere. And then inside the residences, although these are not artificially conditioned, so there's no air conditioning for these residences, which is obviously a very energy intense service that a building has. Instead, they can achieve airflow through some fans or hopefully just the natural physics of being able to open and close the right windows at the right time of day to achieve, cross ventilation or the natural flow of air. So another interesting sort of goal that goes along with what we've been looking at is the idea of a building being carbon negative. And this term carbon negative has to do with the carbon footprint of the building, or sort of how much carbon emissions go into the construction, the maintenance, and the sort of ongoing life of this project. The materials that are used to construct it involve a certain amount of carbon emissions, whether they're, maybe it's the production of concrete or steel. Those materials have to be harvested somewhere. They have to be processed, manufactured, transported to the site. And so in all those aspects, there's carbon emissions involved. And so how can we reduce that carbon footprint? And then once the building's built and occupied and the residents are in there, how can we, further, reduce the carbon footprint of the operations of the building? How people cook, how we might ventilate or heat and cool the building, how we might light the building at night or when we need to artificially light it. So the goal is to not just simply reduce the carbon footprint of a building, but how can we actually go backwards? How can we actually take carbon out of the atmosphere? We know about carbon emissions as a leading contributor to climate change and global warming. How can we actually create buildings that are solutions to that? And so that starts to take into effect all these strategies we've talked about, as well as the idea of urban forestry, that the building itself could be a sort of a forest. You can see an extensive amount of landscaping actually on the building here. How can the building itself generate enough electricity to provide for all of the services in the building? again, lighting and ventilation and cooking and everything that goes along with that. And so this is a strategy that's very much in its infancy, but as designers are, and as the sort of building profession is able to get more and more sophisticated, we're starting to move in this direction. This is kind of the direction we have to go in. And so it's going to be a combination of technology, thoughtful design, and cooperation in some ways that leads us to carbon negative solutions for buildings. This particular building's in Australia. They are one of the world leaders in sustainable building design. So if you ever get an opportunity, take a look at what's going on down in Australia. It's quite impressive. Part of informing our decision-making process, and this is one of the things that we teach at College of Canyons, is what is called whole building energy modeling, and the ability to sort of simulate the effects of how we can naturally ventilate a building. What are the effects of the sun on the building, as far as how it might heat the building, or how we can provide shading to combat that excessive solar radiation. So, designers obviously need to improve and increase their skill sets, and that's something where education can step in and has been to provide those skills and to explore new opportunities for designers to be able to inform their designs, utilizing and harnessing technology. It's rather unfortunate that the building profession has not, up until this point, embraced a lot of the technology that's available. It's as if you went to a doctor and you were complaining of some kind of a problem, and the doctor didn't take any of your vitals. They didn't check your pulse, or check your heart rate, or maybe do a sample of something to determine what's kind of going on with your body. They would be uninformed. But we obviously know that in the medical profession, they do a lot of tests because they need data to determine kind of what's going on. Well, the same thing is basically with the building. Buildings have been called sort of living machines in a way. And so if they are in a certain way living things, then we need to be able to have information about how they're going to breathe, and how they're going to sort of subsist and provide comfortable and effective spaces for people. And so anything we can do to simulate that before the building's built will inform that process and allow us to become more effective with it. So in addition to the sort of technical aspects that we look at as designers, and I think that, on this particular diagram, which is called the quadruple bottom line, a lot of decision-making revolves around sort of the economic and the profitability of things. But we have a sort of another leverage point or motivation for providing safe spaces and spaces that people can thrive in. Our built environments need to be responsive to people. So there's always an aspect of the social in decision-making process. And then we've become more aware over the past 30, 40, 50 years about the environmental and the aspects of the planet that we need to consider in the decision-making process. And so sustainability has sort of traditionally resided or found its most effective application when those three things sort of merge together. When our decisions are made that are responsive to people, planet, and profit, then that tends to be decision making that's moving in the right direction, if you will. But there's sort of a fourth aspect or a fourth consideration that I think a lot of people have become much more aware of or have seen lacking in the built environment that we need to address, and that's the element of purpose. That people require these things that are contained within the purpose bubble to make their spaces meaningful. It's not just enough that a building can be efficient or effective. It's not just enough that it's has a low environmental footprint. It's not just enough that it provides healthy spaces for people, but it needs to touch their their sort of inner their inner spirituality, if you will, to truly be purposeful for the people that live there. And so one of the things that that we do at College of the Canyons is engagement. That's one of the ways that we can provide a sort of outreach to those in Southern California that we want to touch with our ideas about the built environment, and to raise awareness about the built environment, and also to give young people, in particular young students, an awareness of their ability to change the world around them. That they can be change makers in whatever way, shape, or form that takes, whether they're designers or making economic decisions or social decisions or what have you. So we partner up with a group called SoCal NOMA, which is the Southern California chapter of the National Organization of Minority Architects. And so this slide is a summer camp, actually, that's going on right now, 4 successive Saturdays. We're meeting with campers ages 10 to 17 and teaching them about architecture and design, and opening their eyes to the world around them. So engagement's a really important aspect of sustainable design. So with that, thank you very much. I hope this provided an overview of just sort of some of the considerations that architects and designers are approaching in design now and going forward. And I'm happy to entertain any questions or comments if there are any.